Okay, we are so freaking back. Okay, got it. There we go. Advent of Code 2023. I haven't got this code locally yet. Let's go get it. Then we need one of these. Use Flake. And then here and allow. And it should go download our Haskell's and all of our packages and whatnot. So, hey. Okay, the next thing is I need to check some streaming stuff because I haven't streamed in a while. So basically, I'm just checking if it showed up in the Discord that we have. I don't think I have a command for our Discord. Let me check. It should be, if we do, it's bang Discord. Oops. Okay, it doesn't exist, so let me just send a note to myself to add Discord to, what is the thing called? Stream something? Right, we were talking about that. There's my stream setup. Okay, Nightbot, right. So I was using MooBot before. Okay, cool. So there's that. We put that over there. The stream seems to be stable, which is great. It's not blowing up my CPU, which means it's still working on the GPU, which is awesome. And things seem to be going well. I don't know how long this is going to take, but it looks like we're more than halfway through it, so it shouldn't take too much longer. And then hopefully everything just works when I open up my editor. I haven't used this machine in a while. But while that's going, let's talk about what we're doing. So this is day 3, Advent of Code. I've been calling it Advent of Parsers because typically I like to just write parsers for these things. So I have a parser that basically goes through and parses either a number, a dot, or a symbol, which is what this input is, and it's just like a matrix. And the parser is relatively simple in this case because it's not a very complicated input, but sometimes the inputs are a little more complicated, and so you have to you have to write more interesting parsers. So I always write parser combinators for Advent of Code because I just really like parser combinators. They're fun to write, and so I just do that. Now the problem statement here is that we need to grab these things. So each of these numbers are basically what we're trying to grab out of this, but we only care about, they're called part numbers in the explanation, but we only care about part numbers that are next to these gears. And that's what they're called. The stars are called gears. You can see it here. A gear is any star symbol. And we only care about numbers and gears if they're adjacent to exactly 2 of these numbers. Yeah, 2 of the part numbers. So this particular gear is next to this one and this one, and it's next to, like, a diagonal from counts as next to. So this one would be an exactly 2 part numbers, and therefore we can take its gear ratio, which is just multiplying these 2 numbers together. And then if I understand correctly, second key ratio is this. Okay, and then you add up all of the multiplications and you get this number here. Okay, cool. I'm going to do this a lot because I use Pop OS on my other machine, and so it throws me off when I don't have it. It should be, why doesn't that work? Whatever. We'll split this, and then just to make sure that you can always see, whoops, let's move this to about there, and then we should have that. All right. So the code I was working on yesterday is in source day 3. All right. And somewhere down here, I'm working on this search function. So here's search part 2. It's basically a state computation where we keep where we start building up these part numbers. So I always want to search from left to right across the column, and I only want to go through the input once. That's like the main goal. So we keep a list of integers for the current part number. So that would be like 4, 6, and then 7. And then once we hit this dot, we would like collect the number is the idea. And then we also have any adjacent gears, which are also lists of integers. So what I would like to do is create some new types here because I don't want to screw up the part numbers in the gears. So I think I can do, oh, right. There's already something called a part number, a data constructor. There's not a data type. So we can just do part number on part number, and that's going to give me a list of integer like so. And then we'll have another new type called adjacent, or well, it really can just be gear. I think we need to do it like that. Ungear, and that's, oh, actually it really should be gears and part numbers. So like that. And then that way we can actually make these like that. And then we can stick these in here. So this is going to be part numbers. This is going to be gears. Okay. And then here we just need to add our constructors. Gears. Okay. And then this is going to complain 249. Whoops. 249. So the current part number needs to be ungears. And then this needs to be unpart numbers. This needs to be unpart numbers. And this needs to be on gears. Okay, now what's going on here? Right. So the last thing we have to do is repack these things up. So this is a gears, and this is a part numbers. Like so. Okay. So these aren't really super necessary, but when I start doing when I start writing this code into actual functions, it's going to be nicer to have the new types, in my opinion. They're not always like the best. Like for example, here's a good example. Well, maybe it's not a good example, but sometimes we have like row and column, and I'm just going to like default to row. But if we had like literally a new type for rows and columns, it might get annoying. So what I would like to do is I'm going to stick this into a function. And so this thing basically takes a map of the gear data. So it's going to be like F. It's going to take the map of gear to gear data, and we need a list of gears, and we're going to return one of these, I guess. Oh, actually, the whole gear data is the map, so I don't even have to do this. So we can just do that. Okay, so this here is a singular gear, and then this is actually going to be a part numbers. Oops. Which is kind of nice. Okay. And then we will have the gear data and the gears, and then we can just stick this whole fold over here. And this can become F gear data gears, I think. Okay, yeah, we're gonna have to deal with that here in a second. What is this thing complaining about? Oh, it's really not complaining. It's just that that is redundant. Okay. And then, all right, that's an inner gear data. So this is actually a gear map. Okay, let's see where we're failing. So this thing needs to also take the current, like the part number. So basically we've collected. Okay, so at this stage, let me find an, oh, there isn't an example. Let's say this 7 and this star were like here. So if this 7 is at the end of the row, then we need to like put the gear number together. So we'll be sitting on the 7, but we'll have 4 and 6 built up into our part number. So we need to add our 7 to the part number and then like put it against the gear data if there are gears. Does that make sense? So this is going to say gears, and then this needs to be gears, ungears, and then we also need the integer. Then this is going to be x. Let's call it a part number, because that's a better name. Part number. Okay. Then we got to see what it's complaining about next. 268. So this thing returns. Oh, well, this needs to go here, first of all. And oh, that's kind of annoying. Because we do ungears here, we really need to do this. But we're gonna remove this here in a second, I think. So okay, and then this becomes gear map. Like that, I think. All right, and what are you complaining about? Let's see here. Couldn't match expected type on line 244. So unpart numbers should give me a list of integer, and then this should be an integer. This is snock. If you've never seen snock before, it just takes like a list and then a number, and it appends the number to the list. So it's snock. Snock. Well, these are the byte string definitions, but there's a list definition somewhere. Yeah, right here. Like this. List of A to list of A. All right. So let's think about this here. Okay, so our gear data has what? What is our gear data? It's a map to a part numbers. Okay. So that's a list of integers, but this is not a part number. Is that right? All right. So, okay, I got to think about this because apparently I'm uh dumb. Okay, so this is a gear data, which is a map from integer to part numbers. So we need a new map from integer. So the gear should be an integer because we're doing that here. So there's our integer. And then on the right side we have a part numbers. So to number should take a list of integers. What is okay? It combines A's. So the ah okay, but then it doesn't understand how to combine these things because we would need to have instances for them. So I might be able to do deriving new type monoid. Well, I guess I don't think the order matters. Semigroup monoid, is that a thing you're allowed to do? Oh, wow. Okay. So then let's see here. This thing returns just an integer, so I need to do that and that. Okay. 246. What's current? Ah, okay. This does need kind of a lot of information. So I'm wondering if it's actually a good function. And then somewhere down here, the F needs to take the current part number. Okay. So how do we describe this function? I feel like it's going to be kind of hard, but it's taking the goal is that we want to update the gear data. Or next. Oops. Let's call it next gear data. And so it takes the like the state that we've currently built built up, and the like final part number, it's not really just any part number, it's the final part number, and it takes the current gear map and the gears. But the gears are just part of the current part number. So we can actually get rid of this because the gears just come from current part number, current adjacent gears, ungears. Oh, but oh, right. This has become final part number like that. Okay. So we take the current part number, the final part number. This is kind of a bad name, but it is what it is. And then the gear map, and then we'll return a new gear map. But I think that this is probably an okay way to say this. So on 270, we're going to say next gear data. We take the current part number. We take the X, and we take none of that. Okay. Now, the question becomes, the next question is, if the adjacent gears are empty, these two clauses are completely equivalent because our fold will do literally nothing, because this will be empty. So we don't need this case statement here. We can just get rid of these two things, remove this, and we can just put the next gear data for X. So let's call this final part number because that's a way easier to understand name. Final part number. Okay. Then, so this is if the final column, if we're a part number and we're at the final column, we just empty the current part number, get the next gear data map, and we move on. For the case where we aren't at the last column and we have a part number, all we need to do is append the part number and any adjacent gears. So that's what we're doing here. We could probably write a function for this one too, because we're going to probably use it again. So we're going to say like, we're certainly going to take a current part number, and then the things we're going to update are the final part number, which is just a integer, and the adjacent gears, which is a list of integer. And we're going to return a new current part number. So we can say next current. Final. Oh, I see why. Okay, so it's not really the final part number here. It's like just part number. Is that going to be a problem? I'm not sure. We'll find out here in a second. And then this is going to be adjacent gears. And then we can basically just copy and paste this. So let's do that. Okay, and then this becomes number. That we don't need to do that because it will just fix it. 279. Whoops, 279. Okay, and then this can be next current part number, final, no, part number, and adjacent gears. Delete this, delete all of that. What? Oh, it also needs the, there we go. Okay, so we're just trying to clean up a little bit because we're going to reuse these functions, I think, pretty soon. Okay, so if you have any questions, like feel free to ask in chat. Otherwise, I'm just going to kind of ramble until maybe until I'm done, I guess. So now we've like, whoops, that's not a thing. We cleaned up the functions here for when we are a number. So we're currently like iterating through our rows piece by piece. And hey, how's it going, Identity? I am doing swell. Happy, like I finally made it on stream, so I'm pretty excited about that. We had a super good morning with the baby, so we made it. It's like pretty tricky to deal with the mornings right now. So, baby just went to daycare and not ready for like the routine. So it's a little hard in the morning, but we're getting there. So anyway, we're iterating through these one by one. We are collecting our part numbers if they're adjacent. Yeah, it's 8:30 a.m. at the moment. So I have to start pretty much at like 7:45 a.m. if I want to stream, because I really need like a few seconds to like catch up, and then I have like about an hour, but I'll probably stop a little bit early, like 8:50 or so I can make a coffee before work. Yeah, so we're moving left, and then in this case we dealt with the case where this final column contains a number. Now we have to deal with the case where we're like internal to a function and we've hit some symbol. So we're like, we have this current part number thing which collects the part numbers themselves and any adjacent gears, and all the gears are labeled, by the way. So this is actually gear 1, this is gear 2, and that is gear 3. In the parser, the parser does that. Well, okay, that's not actually true. The parser doesn't do that. There's a secondary function which runs through these and then converts the first parser result into the like the input for the second problem, if that makes sense, because the data types for the first part and the second part are slightly different. I'll show you. So in the second part we care about part numbers, which are just like these individual numbers 4, 6, and 7, and then we care about the gears and they're all labeled. In the first part, where's the other data type? All we care about is really a part number. I just called it a number in this case, which is an integer. Same thing as the other case, like a number converts directly to a part number, but we only convert a symbol to a gear if it's a gear, if that makes sense. And then we keep track of them labeled. And then I have a function here somewhere which converts label gears, which is just keeping track of the current gear number in a state, and then we just like go through, fold them, and update the gear number when we need to. So you can see here that like if we get a number, then we just convert it to a part number. If we get a symbol that's a gear, we get the current gear number and like update the gear and then return the gear number. And then any other symbol and a period, we don't care. They're just like nothing to us. So that's what that is. And then what we're working on here is the part 2 piece where we actually solve the problem. So, all right, we are here now. Okay, so if we catch a gear or a neither, I wrote these comments yesterday. So collect the part number and insert it into the gear reset state, which is, or sorry, insert it into the gear, reset the state. We don't actually care about the gears in this case, whether or not we get a gear or a dot is irrelevant because we've already dealt with the gears when we're dealing with the part numbers, right? Like if we get a part number and we see an adjacent gear, we've dealt with the gear. And if we hit like a gear here, it's equivalent to us being like done with the current part number. So because we've already like saw the like we've processed the 4, we've appended the adjacent gear if this thing under my highlight was actually a gear, and then now we've ended the sort of current part number. We've already collected the adjacent gears, and so we're actually done. So whether or not we get a gear or a neither is we're done. That makes sense. So in that case, like we are going to get our state. And we're going to process the current part number by doing this, I think. Okay. So in this case, we don't have like a final part number to deal with. And so this really needs to be a nothing. And this part number needs to be like adjust. So we sometimes have a final part number and sometimes we don't. So that is this maybe part number. And then here we're going to say case. Let's call this M number. M part number of nothing. We'll just take that. And this can now just be a $sign. Oop, not there. Here. Okay. All right. Let's just format that later. We don't care. Okay. And 284. Yep. So this needs to be just. I think maybe I put the just in the wrong place. And 288. Yeah. This will always have a part number, I'm pretty sure. Okay. And just quickly, let's do that. That. Okay. So that deals with the second parameter where we don't have a part number because there isn't one, like a final part number. And then I'm pretty sure we are done. Okay, actually no, we are not done. We are almost done. So now we need a function that takes a gear data and gives us back an integer. Because we need to do the final bit. So we're gonna find, we're gonna go through all the gears, and if there are exactly 2 part numbers, then we'll multiply them and add them all together. So this will take our gear data, and we're gonna need some function from map, but I don't know what. There's probably like a foldle. So we are going to Do we care about the actual gear number? The gear ratio is just them multiplied together. Yeah, so we don't actually care about the key. So that's fine. We're going to get a B, which is going to be our list of integers. And we're going to collect a, which is just an integer that starts at 0. And we'll multiply our gear numbers together if there's exactly 2 and add them to our A. So we can just use full del. We don't need the key. We should be good to go, which is nice because then you can just do map full del. We need a G. G. I can type G, and we're just going to add that to 0, like so. Oh, and then wait, no, that should take. Was this complaining about? Okay, couldn't match type. Oh, right. Actually, we can't do this. We have to do gear data. Whatever. Just do. Okay. If you've not seen this syntax before, by the way, this is the new record dot syntax, and I'm like slowly falling in love with it. It took me a while to get used to, but now I'm like a big fan. All right, what is this G function? This G function is going to take an integer, a gear, no, part numbers, and return an integer. Yeah. So we have an accumulator, and we have a part numbers, and then we're going to say case part numbers dot unpart numbers of. If we have exactly 2, then we're going to say ac. We can't do it that way because we'd have to use the sum monoid if we wanted to do that. X times y, and anything else we just return the accumulator. Okay, so that will so this is a gear ratio function. And this one is like solve 2. Something like that. All right. So now that we are done with that, well, actually, I guess we can probably finish this part. Where do we do the state computation? I don't remember how, like, oh, I just called it part 2. So where's part 2? Okay, so part 2. That's going to take. Wait, did I already have part 2? Oh, I do. Okay, perfect. Let's go back to part 2. All right, so we have our labeled gears. That's this sized sparse matrix of gears. And then we are going to search all the rows So search rows. Okay, so what is this doing here? Okay, so I didn't write a separate fold function. I called it run search. But really we just need to do this, I think. Well, it looks like okay, it does look like I need to do another fold because of the shape of this thing. Right? What do I need to do? I certainly need eval state. And then this is going through the row. Okay, so I need something like this. And okay. Oh, for each of these, it's got to be part 2. Okay. This is empty gear data. Like that. Okay. Then um this will be gears, and I'm guessing it's complaining because of the types. This accumulator is going to be our gear data, I guess. Oh, right. We need to merge these two things together, I guess. So we're going to be like accumulating gear data. Well, no, we don't have to do that because we can just this can actually be just an integer. Because we're just going to be adding them together. So it's going to be like plus, and then let's just say, let's say this, and we'll say gear data equals this whole thing. And then we are going to have like the gear ratios is going to be whatever that function was called that I forgot. Solve 2 gear data, and then we are going to add the gear ratios. Okay, integer. Okay, now let's think about this carefully because I just kind of guessed. Okay. So we first label our gears and we end up with the size. So a sized sparse matrix is literally just a map of XY to an A. I just wanted like I guess it's the second quadrant of a plot. Technically, it doesn't enforce that it remains in the second quadrant, but it's like good enough for this problem. And then we're going to get the current row to search. We're going to collect the gear data for that row. Then we're going to compute the gear ratios, which should give us like a single integer, and then we'll collect the results. And then the final result of this is numbers. Like this, I guess. Okay. Make a run. Oh no. Let's see if it works. It doesn't work. It should be a bigger number. And it's not either of these. So something is very broken. But what? Who knows? Okay. So we're going to need to do some searching here. So let's look at a few things. We don't care about the numbers. We do care about the gears, which is a what? This thing. I'm just going to copy this because I don't feel like typing the whole thing. I mean, it'll autocomplete, but still. Okay. And then that way we can just like, I think we just print it somewhere. Yeah, we just print it so we can look at both those things. Then we should look at what's happening here and here. So we're going to do trace something. And what do we want to put here? We're going to say final column and All right. And then we can like look at these things. And then we will say, give me this thing. Like this, I guess. Just see what comes out of it. All right. So we have 4, 6, and 7. And then we attach the gear, or we should attach the gear. We should print the gear data when it finishes. Let's do that. Oh, right. So here, um, new type. Okay. So we got that. Oops, I shouldn't have done that. Oh well. Now we do this. Okay. Oh, right. Okay. So the gear data. So we go to the second row. There's no gear. Then we get a 35. Why do we get two 35s? Oh, interesting. So, oh, that's tricky actually, because this isn't like a set. You can only add the gear once. But okay, so the trick here is that this gear is actually adjacent to both of these numbers. So we can only well, this sucks. I'm not going to be able to finish this today. I screwed up. So there's a few issues with this. So for this part, the gear data can't like must survive for all rows, right? Otherwise, you're not going to be able to get the right gear numbers. And then the other trick is that the gears, these gears need to be a set. They can't be a list. So let's fix the set part because that will help. So gears here. So we can't have a list of integers because if we have a list of integers, then we'll maintain like gear 1, and then we'll try to insert 35 each time. But the gears are actually just a set. We can only be adjacent to like one time. So this is really a set of integer. Okay, so we're going to do basically like this. We're going to delete our trace, and then we're going to say, well, actually, let's leave trace. I I need to like probably test stuff. So we're going to get set, then we're going to say set qualified as set. Okay, and then 244. This will be a set dot empty. Well, actually, we could just like, you don't need to use the set version. You can just say empty. I assume that it has this. And then 284. Okay, so we're trying to take a set and append with the monoid, or sorry, with the semigroup, but there's no semigroup for set. So here we need to do set insert. I don't know what the shape of that is. So set insert. It is the A goes first. I think that makes perfect sense. So okay. Okay. So where are adjacent? Is there like a set insertion for a list of A? Probably not, right? No, we probably have to do fold all. Set insert this thing adjacent gears. Oops, have to do that. Okay, so that's just flip. Okay. Usually when I write it down like that, then I realize that it's just flip. Sometimes it takes me a second. Okay. Um so now we're collecting them as a set. And I think that should solve the 35-35 issue. Let's just look. Because if it solves the 35-35 issue, then we're just like good to go. Yep. Because this only gets inserted one time instead of two times. So that fixes that issue, but it won't fix the issue where it can't, like, it can't do anything with this because they're separate gear datas. So for each row, the gear data needs to go. So we need to have like another state computation that just maintains the gears, or we're never gonna be able to get this. So our final result should be 0 now, which is like the correct answer because of the bug that we've introduced. And we can fix this later. So let me just clean up one little bit because I don't think we need to show the gear data. I think the gear data is actually correct. The only piece that's wrong is like how the gear data doesn't propagate. So we'll do that. The other interesting thing is that this means that we have another state computation, really, and we can just put the result of mashing the two states together if we would like, instead of using a fold. Or we can just change this fold to like do the union of the things. I think there's I think we could do union with, and then just use the mop-end operator, and it should be pretty easy. But I do need to go like make coffee and go to work. So we'll probably do that like whenever I can next. Um, for anyone who's stuck around for this whole video, I don't know why you did, unless you're just like using my soothing voice as a background noise. I am probably going to start like whenever I'm able to stream. The plan is to start a new book called Professional C++. See, where's my plus sign? Over here. Interesting. Um, there is a new version of this book which I bought, and it should be here sometime in February. And so the goal with this next book is to kind of like go a little lower level, and also get some skills so that I can start working with this thing, the C++ Intel. So this one API DP C++ compiler is built on top of this SYCL standard, SYCL, which I forget what it stands for. SYCL. It's standard. Yeah, from Kronos Group. And SYCL is like a parallel high performance heterogeneous and offload processors to be written using modern ISO C++, APIs and abstractions to find devices on which code can be executed, and manage data resources and code execution on those devices. And so with this thing, you can run on like GPUs or FPGAs or whatever else. And so this DP C++ is like Intel's implementation of this SYCL standard. And so we're going to hopefully like learn how to do this stuff, and then maybe do some like FPGA GPU programming through this. And then like eventually one day in the world, I'll have enough time where I can like actually do quantum chemistry code on stream. But I want to like write it in a way that's not crappy. Um, and I think Haskell will be really hard to write in, because I don't really have a good way to do fast matrix multiplication and like convenient matrix multiplication. Um, Not to say that this is going to be convenient, but it will be fast, and I'll be able to do like all the things that MKL can do, which is like pretty useful. So that's the long-term plan. And that's all I have to say about that. So thanks for hanging out. I will catch you all on another stream, hopefully next week. Hopefully they become more common. Who knows? Goodbye.